Indian rivers and water resumes. A drainage system is the pattern formed by the streams, rivers and lakes in a particular region. That is, small streams flowing in different directions join together to form the main river. This river ultimately drains into a lake or a sea or an ocean. The drainage of India has evolved and adjusted itself with the evolution of the physiographic units. The Himalayas, Peninsular Plateau, and the Indo-Gangetic Plain. On the basis of its origin, the drainage system in India can be broadly divided into two categories: the Himalayan rivers and the peninsular rivers. The Himalayan rivers are perennial. They flow throughout the year. They are fed by river water and water from the melting snow from the snow-capped Himalayan mountains. The three major Himalayan rivers are the Indus, the Ganga, and the Brahmaputra. These rivers originate from almost the same region within few kilometers of each other, separated by water divides. The first flow parallel to the main axis of the mountain, then they take a sudden bend towards the south, cutting through the massive mountain chain to reach the North Indian plains. In the process, they have curved out deep V-shaped valleys. As these rivers flow from the mountains, they carry a large amount of silt and sand along with them. As the rivers flow through the plains, they form lakes and water bodies. Large fertile delta regions are developed as these Himalayan rivers merge with the sea. The Indus system. The Indus originates in the northern slopes of the Kailash range in Tibet near Lake Manasasarovar. It enters India in Jammu and Kashmir. Jhelum, Chenab, Ravi, Beas, and Stalji are the main tributaries of the Indus in India. It covers Jammu and Kashmir, Punjab, and Himachal Pradesh states of India. The word India is a reference to the Indus River. The term is derived from the name of the Sindhu, that is, Indus River. The Ganga system. The Ganga has the twin source. The main one is the Gangotri Glacier, where it is called the Bhagirath. The other is the Satopant Glacier, northwest of the Badrinath, where it is called the Alkananda. They two join at Devaprayag to form the Ganga that emerge from the hills of Haridwar. The Yamuna, Gandak, and Kashi are some of the major tributaries of the Ganga, which starts from the Himalayas. The Chambal, Betwa, and the son of the tributaries which start from the peninsular highlands. The Brahmaputra system. The Brahmaputra rises from the snout of the Chamayandang Glacier of the Kailash range near Manasasarovar. The Brahmaputra river is longer than the Indus. It mostly flows outside India. It flows eastwards through southern Tibet. Near Lonsei Dzong, it opens out into a wide navigable channel for about 640 kilometers. Thereafter, the rivers break through a succession of rapids. It enters in a great loop southwest through Arunachal Pradesh in India, first as a Shang and then as a Dang. It is joined by Dang, Lohit and many other tributaries and finally forms the Brahmaputra in Assam. The Brahmaputra is marked by huge deposits of slit on its bed, causing the river bed to raise. It also shifts its channel frequently. The peninsular rivers. The peninsular rivers are seasonal. They do not flow throughout the year. They are dependent on the rainfall in that region. These rivers are not as long as the Himalayan rivers. Most of the peninsular rivers start from the Western Ghats and flow towards the Bay of Bengal. Some peninsular rivers start in the highlands and flow westwards. Most of the major peninsular rivers, except Narmada and Tapti, flow from west to east. The Chambal, Sindh, Betwa, Ken, and Son originated in the northern part of the peninsula below to the Ganga river system. The other major river systems of the peninsular drainage are the Mahanandi, the Godavari, the Krishna, and Kaveri. The Godavari is the largest peninsular river system. The source of this river is in the Triambak Plateau near Nasik in Maharashtra and discharges its water into the Bay of Bengal. The Godavari originates from the slopes of the Western Ghats in the Nasik district of Maharashtra. It is the largest of the peninsular rivers. The Krishna originates near Mahabaleshwar and drains into the Bay of Bengal. It is the second largest east-flowing peninsular river. The Mahanandi rises near Sihava in Chhattisgarh. It flows through Orissa to reach the Bay of Bengal. The Narmada rises in the Amarkantha hills in the Madhya Pradesh. The Tapti originates from the eastern Satpura range of southern Madhya Pradesh state and flows westwards. It flows parallel to the Narmada and is shorter than the Narmada. Water use. Water is the resource that becomes available to us as an annual flow. That is, we try to estimate how much we would be able to use during the year. In order to do this, we need to recall the water cycle and estimate the inflows and outflows during the year. Inflows and outflows can be estimated at different levels for small watershed or an entire river basin. Now, let us explore the idea of a water budget as it would apply to a small or large region such as a village or a district. Inflow. For any area, inflow equals to precipitation plus surface flow plus groundwater flow. Surface flow includes rivers, streams, canals, and other flows on the surface. Groundwater flow is difficult to estimate, but it can be done. Precipitation includes snow, dew, hail, etc. To estimate the precipitation of an area, we take an average over many years since precipitation varies from year to year. Surface and groundwater flows. Surface water is water on the surface of the planet such as in a stream, river, lake, wetland, or ocean. Groundwater is found underground in the cracks and spaces in rocks, soils, and sands. However, it is more difficult to get an idea of groundwater inflows, but the general slope of the land helps one make a guess as to the possible direction of the flow. Outflows. Evapotranspiration. Evaporation is the process by which water changes from a liquid to gas or vapor. As the temperature increases, the rate of evaporation also increases. The amount of evaporation depends on the temperature, and it also depends on the amount of water there is to evaporate. Transpiration is the process where water contained in liquid form in plants is converted to vapor and released to the atmosphere. Most of the water taken up by plants is released through transpiration. The total amount of water added to the atmosphere from both evaporation and transpiration is called evapotranspiration. Water flowing out via surface flows and groundwater. Imagine a region such as a village. Some amount of water would flow out of the village as surface flows through streams. This surface flow would increase substantially during monsoon months. A portion of the rainfall percolates into the soil and travels to the underground strata and recharges the aquifers. Some of it flows into and becomes available for use through wells and bore wells, and a portion of it goes into every deep aquifers that do not become available. Water for agriculture. The amount of water involved in agriculture is significant, and most of it is provided directly by rainfall. Agriculture uses approximately 70% of the world's freshwater supply. Though rainfall or some process of irrigation, water reaches the root zone of crops. Soil has a capacity to store moisture. If there is excess water, such as flood, and this is not able to prelocate below it, would damage the roots. On the other hand, in a drought situation, if there is not enough moisture in the root zone, the crops will wet. Water use for domestic purpose and for animals. Water used for drinking, cooking, bathing, washing clothes, cleaning dishes, and for animals is vital. Planning for this component is needed to increase the availability so that a minimum amount is actually made available to all, irrespective to their income. Water for industrial use. Water used for industrial purposes may be incorporated into products or used for processing, cooling, maintenance, etc. In India, industry is the second highest consumer of water. The main source of water for the industrial sector are groundwater and surface water. Water is required for manufacturing processes is more than compared with domestic and agricultural uses. This demand often competes with domestic and agricultural uses. This needs to be taken into account as this conflict is on the increase. Most villages in India draw water from tube wells and wells. Most of villages are dependent on groundwater storage. These inflows and storage are connected, while some of the water flowing in is used directly. One part of this is recharged or replenishing the storage. Similarly, the use of tube wells draws from storages and lowers the water available in them. Depending on comparative rates of inflow and outflow, one can judge what is happening to the stock of water over many years. The annual flows and stocks that recharge wells and tube wells is the water that is available for use. Everyone should keep their needs in this range. Water use in the Tungabhadra river basin. Tungabhadra river is a tributary of the larger river system Krishna. It is a holy river in the South Indian peninsula that flows from Karnataka to Andhra Pradesh. This river is formed when Tunga and Bhadra rivers meet, thus giving it the name Tungabhadra. It originates in the Western Ghats with a catchment area of 71,417 km per square, of which 57,671 km per square area in Karnataka. The Tungabhadra basin has two parts: the upper and middle catchment in Karnataka and the lower portion of the catchment in Andhra Pradesh. According to official statistics, farmland is the main land cover in these states. Others such as trees, groves, fallow land, cultivable waste, permanent pastures, forests, and natural vegetation cover the rest of the area. The lower portions of the basin in Andhra Pradesh are characterized by lower rainfall and drought conditions. Some regions depend on rainfall and underground water, that is, wells and tube wells for agriculture. Some other regions depend on surface flows by canals that carry water from dams built along Tungabhadra, encroachment of public lands for cultivation at the expense of tree cover, rampant felling of trees and mining activity is resulting in forest degradation, along with the destruction of the habitat of highly threatened flora and fauna. Inflows of groundwater depend on the tree cover in the catchment areas. Inadequate tree cover leads to water runoff as surface flow without getting a chance to recharge the underground water. Moreover, this also causes flash floods. Tungabhadra Dam has gradually lost its water storage capacity over the decades. About 50 years ago, the capacity of the reservoir was 3,766 million cubic meters. Now, with accumulation of slit due to mining, dust, soil erosion, debris, the reservoir has lost its storage capacity by as much as 849 billion cubic meters of water. As one study says, no proper mining standards are followed in iron ore extraction. The mining of iron ore at Kudiremuka and Manganese in Sondur has seriously affected the stability of the catchments in the form of soil erosion and siltation of several small reservoirs, traditional tanks and Tungabhadra Reservoir. Conflicts between Karnataka and Andhra Pradesh are generally related to usage of Tungabhadra river water. Based on agreements between state governments, these states have been sharing the Tungabhadra river water. Access to water is a precondition in this farmland area where 80% of the population depending on agriculture for their livelihood. Irrigation is provided through canal systems and bore wells. The major crops grown include paddy, jowar, sugarcane, cotton, and finger millet. Although the area is ideal for semi-acid crops, the major crops grown demand a lot of water like paddy and sugarcane. Cultivation of such crops throughout the basin has dramatically altered the water-sharing balance. When all areas desire water for these crops, conflict becomes inevitable. During the last 2 decades, there has been an increasing trend in the number of small towns and industrial areas. This has made competing demand for water more complex. While increased industrialization and growth of urban area have improved standards of living of some, the same activities have caused population, especially by industrial units. There are 27 functioning large units and 2,543 small units in this river basin. They consume a big amount of water per day. Industries were permitted to discharge effluents into the river, but following public protests in 1984 regarding discharge of molasses that killed fish on a large scale, laws were enacted requiring industry to discharge only treated effluents. These laws are not implemented forcefully. Hence, severe pollution of the river system continues. There has been a mismatch between keeping pace with development activities on various fronts and providing drinking water supply for all sections of society, both in small towns and rural areas. Thus, the socio-economic aspects are of very important to water use management. Conflicts within communities in a region and across sectors such as use for agriculture industry or drinking water are common. Apart from this, interstate disputes between Karnataka and Andhra Pradesh arise due to the transboundary nature of the river. Rational and equitable use of water. An example. We have read about the use of water and the need of look at all the inflows and outflows so that a judicious use and with fairness can be worked out. This could be for a river basin or a village. Such plans and implementation schemes are possible. Highway Bazaar village is an example. Highway Bazaar was selected under the Adarsh Gram Yojana of Maharashtra government for watershed and all-round development of the village. Highway Bazaar is located in Ahmednagar district in Maharashtra. It is situated on the eastern side of the Sahyadri mountain ranges that run north-south and separate Konkan, the coastal region, from the rest of the Maharashtra. Ahmednagar district is drought-prone with an average rainfall of about 400 mm. The soil and water conservation works in Highway Bazaar were implemented on common lands and on private grasslands. Continuous counter trenches were dug on the hill slopes to arrest the erosion of soil, harvest water, and encourage growth of grass. A number of water harvesting structures were also built in the village: check dams, percolation tanks, and loss-bounded structures. Plantations on forest lands and roadsides were also part of the program. When Adarsh Gram Yojana was launched in Maharashtra, there were also some preconditions set for selection of villages. Most important were the four bandis or bands made famous by the Rolegon city experience. The four bandis were Kurhat Bandi, Charai Bandi, Nas Bandi, and Nasha Bandi. People also had to agree to a certain amount of Shramdan, except for the landless who were exempt from it. The significance of these five ideals needs to be understood, keeping in mind the situation in Khyber Bazaar at that time, the late 1980s. The surrounding epochs, according to many local people, had a barren look. Soil erosion was prominent and groundwater leaves very low. In addition to this, fodder and fuel wood storage were common in the village. Though there was a ban on free grazing, people were allowed to cut grass to feed animals. There are other bans in the village which were added later. Most significant was the ban on bore wells, of irrigation growing sugarcane and banana, and selling one's land to any outsider. These measures illustrate that issues of long-term sustainability were very much central to the strategy. The area irrigated for summer crops has increased from 7 ha to 72. Even in the unirrigated land, the improvement, however, one of the learnings has been that groundwater extraction cannot be controlled at a small unit or within a village boundary. Neighboring villages started going for deep bore wells and started extracting groundwater, over which Khyber Bazaar had no control. Hence, we need institutional norms and understanding at a much larger unit, that sub-basin or river basin. Water as a common pool resource. Over the past few decades, groundwater has become the main source, especially for domestic use and agriculture. This tremendous increase in the use of groundwater has significant impact on water availability and access to it. The current laws about groundwater in many states are both outdated and inappropriate. They were developed at a time when groundwater was marginal source of water. Today, shallow and deep tube wells have the potential to draw a lot of water. Current laws on groundwater use as inappropriate because the basic link between access to groundwater and land ownership on which these rules are based are flagged. Since groundwater has to be extracted from the land above, a link was established between land ownership and control. The water drawn from the underground system was assumed to be owned by landowner. This implies that groundwater is mostly controlled by individuals that own the land. Landowners were not restricted in the amount of water they can take out. Underground water does not obey human land ownership boundaries that are made on the surface. Water is a flowing resource, and what is extracted from an individual tube well or well depends on the groundwater rock formation, the recharge from rainfall or surface water. All these factors are happening over a large area. Hence, the actions of others in the region will affect this particular well. For example, over-extraction from one tube well often dries up other tube wells around. It is therefore inappropriate to think of ownership of a flowing resource such as water and air. Similarly, there are no boundaries in the flowing water underground. Today, underground water is the major source of water for people. When there is no much extraction, it affects the stock of water that would be available for further generations. Therefore, one cannot allow individual landowners to extract as much water as they wish from their land. There should be some restrictions. These restrictions will be applicable if we first delink the connection between ownership of land and water drawn from the groundwater system through tube wells on the land. Where control over groundwater is linked to land rights, that are no pressures on individual landowners to use water in fair water. Nor is there any way to implement policies that take into action and welfare of a bordered community and the environment. Some form of regulation that takes into account the border aspects of groundwater use is necessary. Therefore, water should be thought of as a collective pool resource that is meant for all people. Similar to roads, rivers, and parks, underground water is also public property. It belongs to all. Regulation is not easy. This is also because for some resource like water, electricity, oil, natural gas, etc., consumption by one person or a sector affects others. In fact, in a number of states, the answer to falling water tables has been not to address the issue itself. State governments have thus often chosen to increase power subsidies to make extraction of even deeper layers of groundwater possible. The limit of an approach that not only refuses to control access to groundwater but seeks to encourage it with specific subsidies have been clearly understood. The political thinking has to change to make regulation work. This is the only way to stop the negative competition to finish off the common pool resource, since each person wants their share before someone else. This is the real contemporary challenge. Drinking water is the first priority as well as a human right, and that Panchayati Raj institutions must have control over the use of groundwater. Let us see the dispute over water use between the Perumati Grama Panchayat in Kerala and the Coca-Cola Company. The Panchayat decided not to renew the license of extraction of water because of the lowering of the water table in neighboring areas. There was also decreasing water quantity to the extent that the local government primary health center had concluded that the water was not fit for drinking. The issue was brought to the courts. The two discussions given by judges in Kerala gave two opposing views of groundwater regulation. The first judge found that groundwater is a public resource meant for all, and that the state has a duty to protect it against excessive exploitation. Additionally, the judge made the link that drinking water is a priority. The second judge took a completely different perspective and asserted the primacy of landowners' control over groundwater. In conclusion, in the first section, we looked at the river systems and the diverse physiographic conditions in India. Water use for any region, whether small watershed or river basin, has taken into account all the inflows and the outflows. We have also read about Tungabhadra river basin. We looked at the effort of the people of Highway Bazaar village and hope that people all over would be inspired towards creative action in their situation. Water resources require both collective action at the local level and appropriate laws and policies at the state and national level. Through the example of groundwater, we can understand the shortcomings in our thinking today. It is very important to protect the scarce water resources from being polluted.